For 68, we're asked to graph this piecewise function and then determine if it has a left-sided limit, a right-sided limit, and then if those two equal one another, it should have a two-sided limit. Now, it's a piecewise function, and I think since we are in AP Calculus, I can show you guys how to graph piecewise functions in the calculator. So what you want to do is you want to take the first function, which is going to be 1 divided by the quantity x plus 1, and make sure that that's in parentheses. Directly next to that, we're going to open a second set of parentheses, and we're going to say, for x, hit second math, which pulls up the test menu, and we want to know for x greater than -1. And so what that does is for that particular expression, it's only going to evaluate it at x greater than -1. Now, if I hit plus, that's kind of like an and, then I need to make sure I put in parentheses the second expression, x squared minus 3x, and close my parentheses, and then right after that I'm going to say x second math, which pulls up the test menu, and this time we want to select less than or equal to -1. So now when I graph that, I'm going to get like this. It's supposed to be a piecewise function, but you'll find that the 1 function actually approaches positive infinity as we take the limit on the right hand side. So let's talk about the limit from the left hand side. If I go to negative 1.01 and I hit enter, I've got 4 point something. So it looks like it's approaching 4. So A is out because A asks for the left-sided limit. In other words, as we come in from the left side, from negative infinity, as we come this way, what is my y value? Well, it looks like it approaches 4, so A's out, B's out, and so I'm left with option C or D. Now, truthfully, we have enough information to solve this, right? In order for the two-sided limit to exist, A and B, the left-sided limit and the right-sided limit, have to equal the same. And so C is not the right answer either, because this is the limit from infinity, from negative infinity. This is the limit as we approach from positive infinity. And, well, they don't equal the same, so there's no way that there could be a limit of 4. So D is our correct answer, and let me just pull up the graph again to show you why. See, as I approach from the left-hand side, I approach 4. So right before I get to -1, I'm going to approach 4. But when I get to x equals -1, nothing exists. And the reason for that is, as I approach from positive infinity, in other words, as I come in from the right-hand side, notice what happens to my y values as I get closer and closer to x equals -1. It just kind of skips over. But see how this line comes in? So if I say -0.99999, which is really close but not quite it, I'll get this. But if I come in from -0.999, because the calculator can only approximate, notice as I get really close to -1 from the right hand side, the y value is blowing up. So technically the limit, it doesn't exist. There's no y value, but if we talk about limits as x approach -1, clearly this approaches infinity. So if we were taking limits, we would say that A is 4, B is infinity, but it doesn't ask that. It says determine the limit if it does not exist. Well, it's an infinite limit, and we haven't talked about that yet. But clearly, the left-hand sided limit and the right-hand sided limit are different values, and so the two-sided limit does not exist.